The topic is continuous functions of two variables. So let's do the first example. Question A of the first example: determine all points at which f of xy equal x cubed minus xy over 1 minus x squared minus y squared is continuous. Now again, by looking at the definition, polynomial, rational functions, radical, logarithmic exponentials are all elementary functions. And not only that, we know that elementary functions are continuous on their domain. Composite functions are also of elementary functions are continuous on their domain. But for this example, all we care about is polynomials, right? So continuous on their domain. In other words, we need to find the domain. The domain is what? Is the set of all xy's such that f of xy is defined. F of xy is defined if the denominator is not equal to 0. What does that mean? That means minus x squared minus y squared, subtract 1 from both sides, is not equal to negative 1. Divide by negative 1 or multiply by negative 1. You don't want this to be 1. In other words, it's the whole R2, and all I need to exclude is the unit circle. So all this stuff, it's continuous at all these points, even the inside. The only place that's not continuous is on the points of the circle x squared plus y squared minus y. In other words, it's the xy plane minus the disk x squared plus y squared equal to 1. Alright, so let's answer question B. Is f continuous at all points in the region x squared plus y squared less or equal than 1 over 4? Now, it's negative 1, 1, negative 1, 1. We know it's not continuous at these points of the circle. However, x squared plus y squared less or equal than 1/4 is this disk. 1/2, right? The radius is, let me rewrite it, x squared plus y squared less or equal than 1 over 2 squared. So the radius is negative 1/2. So this is the region, and we can tell the function f is continuous. So the answer will be yes, f is continuous on the disk x squared plus y squared less or equal than 1/4. Why? Because it's continuous at each point there. We don't have a problem. Now, is f continuous at all points in the region x is between negative 1 and 1 and y is between negative 2 and 2? So first thing I want to do, negative 1, 1, negative 1, 1. So this is my circle, the original circle. Now I want x to be between negative 1 and 1, from here to here, and the y to be between negative 2 and 2. So y will be between negative 2 and 2. So what do we mean with that? Let me use, meaning this region. So is f continuous on this region? Of course not. You can use any point. You can use, for example, this point. So f is not continuous at the point negative 1, 0, because it's not in the domain. Therefore, f is not continuous on the region R. What I mean with the region R means all this. But there are a lot of points you could pick. You could pick this point also, you could pick this point. All we need one point to show that it's not continuous on the region. Right, let's move on to the next example. Determine all points at which f of xy equal e to the y plus square root of minus x squared plus y is continuous. Again, this is, by the way, composite functions of elementary functions. So we know, according to the theorem, that the composite functions of elementary functions are also continuous on their domain. Again, I need to find the domain. The domain is the set of all xy such that f of xy is defined. In other words, I want whatever under the radical to be bigger or equal than 0, which means I want y to be bigger or equal than x squared. Well, I did add x squared to both sides. Now, what do I get? Here's the curve or the parabola y equal x squared. So I want all this region, the region that's above the parabola, right? Now let's answer question B. Is f continuous at all points in the region? By the way, I didn't write the question. X is between -1 and 1, and I think y is between (0) and 2. Alright, so let's see. So first thing I do, I'm gonna plug y equal, this is y equal x squared, right? I'm gonna go to -1 and do this line. I'm gonna go to 1 and do this line. I know that if you plug it into x squared, I know this y value is 1, right? But the question is f continuous from x between -1 and 1 and y is between 0 and 2? In other words, we want this rectangle. So, I mean, it's easy. Just pick a point, for example, here. This could be what, 1/2, right? Remember, if you plug 1/2, if I plug 1/2 into x squared, if x is equal 1/2, then y is equal 1/2 squared, which is 1/4. So I know this point, this y value is 1/4, so I'm just going to pick any y value y smaller. So 1/2, for example, 1/8. So if I pick the point 1/2, 1/8, so I can say f is not continuous at the point 1/2, 1/8. Therefore, f is not continuous on our region R. What is our region R? X, the rectangular region, x between -1 and 1 and y between 0 and 2. And that's it for these examples.